into another question, which is it possible, is it possible to have two vectors, is it possible to have two vectors of different magnitude, different magnitude have to have zero resultant, zero resultant? Can three? Okay, so we have this question, and the simplest way to do this is to find something like a counter example. If you find a counter example, it's the simplest case. If you don't find a counter example, you must be a lot more think about it a lot more. So first of all, let's find it for two vectors. So I'm using another color, which means this is not my answer, rather this is my thinking. So when we use two vectors, let's see the possibilities. Let's use two random vectors. Let's say one vector, let's say vector A has a magnitude of 1, whereas vector B has a magnitude of, let's say, 3. So we know that the maximum value that we can get is the sum of these two vectors, which will just be 4, whereas the minimum is gonna be 1 3 minus 1, which is 2. So the question arises, this definitely does not include 0, so doesn't include 0. So the question that arises is this a special case, or is this a general case that you can apply for any other thing? So let's think about two vectors and what can result in zero resultant. So if you think about it, so I will do this in another page. Let's take a ball. Suppose you have a ball and let's change its color to orange. Why not? So you have two forces. One force, or let's say ropes. You have two rope. I'm gonna take one rope, I'm gonna make it a lot thicker, and let's make it white, because why not? And let's take another rope and let's keep it on the other side, so exactly opposite on the other side. And let's take blue. So if I do this, my question for you is, in what case, like if there is a force, let's say F1, so there is a force F1 over here, and there is a force F2 over here. In what case will there be a case where the ball does not move at all? And if you ask me, I would say if the force over here is equal to the force over here in terms of magnitude, I would say that the ball will not move. So let's say there is 3 newtons over here, which means that here also must be 3 newtons. So as we can see, we found a way to get 0, but 0 involves both of them having the same, both of them to have same. So as what I'm trying to say is, for two vectors to have 0 resultant, we found a case where two magnitudes of vectors must be same to have 0. But let's see, if I change the angle for say, so let's just take this and take it to another page. Let's remove all of this, so we do not need this. So if we just take this and we rotate this, so if I rotate this, so let's say I rotate it over here. If I rotate this over here, obviously you will get a resultant going somewhere around here. Let's rotate this much more farther. You will still get a resultant over here. Even if you get very close to the line, so this line, you will still get a small resultant over here. So as you can see, there is a parallelogram. I can clearly form a parallelogram, so you can get something over here. Let's move it downwards. If I move it downward, there's still a place where you can get 0 resultant. So as you can see, there is only one place that can create 0 resultant, which is exactly opposite to each other, and both have same magnitude. So if that's the only case, then if we change magnitude of any one of the vectors, it does not matter where we put it, we will never get 0 resultant, since the only possible way to get 0 resultant would be to have two vectors exactly opposite to each other, and have the same magnitude, if that makes sense. So that's the answer of the first thing. Now obviously, let's find the answer for the second thing, which is tan 3. So tan 3, that's the very logical question. So let's just find a way. So first of all, let's try to find a way where we can do this. um, so let's try to find a way where we can do this. So I'm just going to copy this vector. Why not? So let's say this vector is um, let's make it to that. I'm thinking, how should I do this? So let's make this the ball. Let's make this vector vector f1, right, of 3 newtons. Because why not? Let's just say this is 3 newtons, and let's have 2 more vectors. Since we're talking about 3 vectors, we just need to find a case. If you can find a case, then we are golden, right? So let's rotate this vertically, horizontally. Copy that, move that. Let's move that one right over there. Let's make it a lot smaller, and let's move this another one, and let's move it like that. I will change the color to blue and this to purple to make it much more clear. Let's just say this is our second force, and if you're following me, I think you have already found a way to get zero resultant with different magnitude. This is 1 Newton, let's say, and then this must be 2 Newtons, since this blue line is 2 units wide. So as you can see, there are 3 different, the units are different, so like the magnitudes are different, but in this case you can certainly get a way where you get that 3 vectors will result in 0. So let's write the answer. So the answer will begin from here. So it is not possible, it is not possible for 2 vectors of different magnitude to have zero resultant. But it is possible for 3 vectors. It is possible for 3 vectors if the resultant of 2 vectors is equal in magnitude but opposite in direction with the third vector. So if you remember one of my previous video, I also said there were like 3 vectors, let's say 1, 2 and 1, and there was a question if these 3 vectors can result in 0 acceleration or 0 something. So yeah, it's obviously because the sum of the other ones is greater than the maximum or equal to that. So it's 2 is greater than or equal to 2. So this was the condition and this was reached. If you don't understand what I'm saying, go watch that video. Let's plug that in as well. So what does this mean? The resultant of 2 vector equal in magnitude but opposite in direction. In this case, like both these 2 vectors lead to have 3 newtons, right? That's why this 3 newtons and this 2 newtons cancelled out to give us 0. But let's suppose there is a case where that the angles are not exactly on this, whereas they are rotated by something. So even if they are rotated, if you remember of the triangle law and parallelogram law, you can obviously have a resultant that is 3 newtons. Like obviously, even if the values of this are different, even if the angle are different and the values are greater, you can have a case like there is a possibility to have 3 newtons even if there is a parallelogram or triangle. So that's why we are talking about the resultant. I think I explained it pretty well. Not sure, but so that was it for today's video. In the next video we are gonna do another question. Till then, bye bye.